our first example with these double angle formulas, we are going to find function values of 2 theta given information about theta. Okay, so let me explain what that means. Okay, so theta is an angle. If you double it, you're going to get 2 theta, which is a different angle. Okay, so you are going to be given information about theta. So for example, you might be given its sine value or its cosine value or the quadrant that it's in. You're going to be given some type of information about the angle theta. And then from that, you are going to have to find various trigonometric functions of 2 theta. Okay, you might have to find the sine of 2 theta or the cosine of 2 theta or the tangent of 2 theta or so, and so on. Okay, so you're using information about the original angle theta and using that to produce values of 2 theta. Okay, so let's look at example 1 here. It says, given that the sine of theta is equal to negative square root of 5 over 7 and the cosine of theta is greater than 0, find the exact value of the sine of 2 theta. Okay, that's part A. This example continues into the next page. We are also going to have to find the cosine of 2 theta as well as the tangent of 2 theta. All right, so first notice everything that we've been given, the information, it's all about theta, not 2 theta. Okay, the information that applies to theta is different from what's going on with 2 theta because they're 2 different angles. Okay. All right, but we can use this given information to get what we need. Okay, so let's start by looking at what we're trying to find. Okay, so we need to kind of process that, and then that will point us in a direction of how we can use what we've been given. Okay, all right, so the sine of 2 theta, that is a double angle formula. As soon as you see that 2 theta, it should be screaming in your head, double angle formula, double angle formula. Okay. So what we're going to do is go and grab our double angle formula for sine. There's only one double angle formula for sine. So the sine of 2 theta is going to be equal to 2 times the sine of theta times the cosine of theta. Okay, I'm going to write that down. This is going to be 2 times the sine of theta times the cosine of theta. Okay, so to do this calculation, all you need is the sine of theta, which guess what? We already have. It's right here, but we also need the cosine of theta. We don't have the value of the cosine of theta. We just know that it's positive. So we're going to have to figure that out. And then once we have it, we're essentially done. Okay. All right. So let's talk about how we would do this. I'm going to go out to the side and try to figure out the value of the cosine of theta. Okay. So we know that the cosine, okay, let me write this. For theta, okay, what do we know? Okay, I'm trying to figure out what quadrant theta is in. I know that the sine of theta is negative. Okay, so it's got a negative sine value and its cosine is positive. Okay, so what quadrant is this happening in? Where the sine is negative and the cosine is positive. Okay, that's quadrant 4. Okay, so that's where this angle theta lives. Okay, 2 times theta probably lives in a different quadrant. Okay. You've got to keep your angles separate. All right, so I'm going to draw a picture here. I'm going to draw some angle in quadrant 4, and that's going to be theta. Okay, so here we go. All right, so here comes the terminal side of the angle. And then I'm going to draw back to the x-axis to make a right triangle. Okay, so start at my terminal point, straight back to the x-axis. Here's my right triangle. Theta is the angle formed by the terminal side and the x-axis. So it's this angle right here. Okay. And we are told the value of the sine of theta. Okay. We know that the sine of theta is the negative square root of 5 over 7. Okay. So this is going to allow us to label the sides of the triangle here. Okay, we know that sine is opposite over hypotenuse. Okay, hypotenuse has to be positive. Okay, so the hypotenuse here has to be 7. And then if we equate at the tops of the fraction, we're going to get that the opposite side needs to be labeled with negative square root of 5. All right, so here we go. In labeling our triangle, okay, let's label the sides here. If we have theta here and we go straight across, this is the opposite side. It needs to be labeled with negative square root of 5. Okay, makes sense. This is a negative y value in the fourth quadrant. Okay, and then if we go across from the right angle, this is the hypotenuse. It needs to be labeled with 7. And then the other side is the adjacent side. Okay, we don't know it. We're going to have to figure it out. Okay, Pythagorean theorem. Okay, so I know that c squared has to equal a squared plus b squared. All right, I'm going to plug in what I know. I know the hypotenuse is 7, so I'm going to get 7 squared is equal to a squared plus the opposite side is negative square root of 5. We have to square that. So we're going to get that 49 is equal to a squared plus the negative squared will turn it positive, and then square root of 5 times itself will give you 5. Okay, and then I need to solve for a squared. Okay, so subtract the 5 from both sides. I'm going to get that a squared is 44. Okay, so a is plus or minus the square root of 44. Okay, so we have to decide, do we want the positive or the negative version? Okay, so if we look at our picture again, we're in quadrant 4. The adjacent side is coinciding with the positive x-axis, so we need to pick the positive value. Okay, so this is going to be positive square root of 44. And before we go on, I'm going to go ahead and simplify that. 44 breaks down into 4 times 11. So if you do the square root of 44 and you broke this down, this is the square root of 4. Well, let me do it this way. You can break this up in, well, okay, I'll write it this way. 44, the square root of 44 is the same thing as the square root of 4 times 11, because you have 44 underneath the radical. But then you can break it up as the square root of 4 times the square root of 11. So it's the same thing as 2 times the square root of 11. Okay, if you wanted to simplify your square root. So I'm going to say that this adjacent side, you can say it's the square root of 44. That's equivalent to 2 times the square root of 11. Okay. All right, we have all 3 sides of our triangle labeled, so we can go ahead and say what the cosine of theta is. Okay, the cosine of theta, this is going to be the adjacent over the hypotenuse, and so that's going to be 2 square root of 11 over 7. All right, so now we've got the value of the cosine of theta, we've got the value of the sine of theta. We can plug and chug into our formula. So we're going to get that the sine of 2 times theta is equal to 2 times the sine of theta, which is negative square root of 5 over 7, times the cosine of theta, which is 2 times the square root of 11 over 7. And then we just have to multiply this stuff together. All right, so we're really just multiplying fractions here. The 2 is over 1, so we need to multiply across the top and across the bottom. So I'm going to do the bottom first because it's easier. 1 times 7 is 49. And then I'm going to go across the top. The top is going to be negative because we basically have positive times negative times positive. 2 times 2 is 4. Okay, and then the square root of 5 times the square root of 11 is going to be the square root of 55. Okay, and so that is our answer. The sine of 2 theta is negative 4 times the square root of 55 over 49. Okay, again, 2 times theta is its own angle. If you compute its sine, it's going to be this exact value. All right, let's go on and now try to find the cosine of 2 theta in part B. All right, so the first thing I'm going to do is apply a double angle formula. Okay, so let me go back to page 1. I'm going to look in the box. Which formula should I use? Well, now it's a bit of an issue because there are 3 different formulas for the cosine of 2 theta. Okay, So here's what I want you to think about. Okay, which one is going to suit us best? Well, when you look at it, this formula right here, okay, um, the information that it's good. Look at it this way. Okay, on the left side, okay, each one of these guys tells you how to compute the cosine of 2 theta. Okay, so you really got to pay attention to the right side. In this first one, you're going to need the sine of theta and the cosine of theta. We have that information. In the second one, you're going to need the sine of theta. We got that. In the third one, you're just going to need the cosine of theta. Okay, so actually, it doesn't matter here. You can pick any of the formulas you like. Okay, they're about, all of them are essentially equal in terms of which one's the easiest or most difficult to use. They're all about the same. Okay, so I'm just going to pick one and go with it. Okay, I'll just pick the first one. Okay, so I'm going to use the cosine of 2 theta is equal to the cosine squared of theta minus sine squared of theta. Okay, so I'm going to go and jot that down. This is the cosine squared of theta minus the sine squared of theta. Okay, and now I can plug in my values. I've already done the hard work. Okay, the hard work was doing all this stuff with the triangle to come up with the value of the cosine of theta. Okay, I'm good to go. I know the sine of theta, I know the cosine of theta. Okay, so I'm going to plug into this. Remember, this is cosine of theta times the cosine of theta minus the sine of theta times the sine of theta. All right, so I'm going to go ahead and grab my cosine of theta. The cosine of theta is 2 square root of 11 over 7. Okay, so 2 square root of 11 over 7. We need to square that or multiply it by itself. And then we're subtracting. We need to go get the sine. The sine was given to us. It's negative square root of 5 over 7. We're going to square that. And then we're going to simplify and we will be done. Okay, so let's multiply each pair of fractions. If we start with this first pair of fractions, I multiply across the bottom, I'm going to get 49, and then multiply across the top. 2 times 2 is 4, and then square root of 11 times itself is going to be 11, and then we're subtracting. When we multiply the second pair of fractions, minus times minus will give us plus, so this minus will still stay in the middle. The denominator will be 49, and then multiply across the top. Square root of 5 times the square root of 5 is going to give you 5. All right, so this is going to be, we're subtracting 2 fractions over 49, so combine them into 1. Go across the top. This is going to be 44 minus 5. Okay, and so the answer here is 39 over 49. We're done. Okay, again, you have an angle theta. You double it to get a different angle 2 theta. And if you take the cosine of that new angle 2 theta, the result is going to be 39 over 49. Okay. All right. Lastly, okay, we need to compute the tangent of 2 theta. Okay. We're going to do this like we've done parts A and B. Okay. We're going to start off by writing down a double angle formula. There's only one for tangent. Okay, so go and grab it. It is on page 1. It's formula 5 here. So this is going to be 2 times the tangent of A over 1 minus the tangent squared of A. So if we translate this, we're going to replace A with theta. So the tangent of 2 times theta is going to be 2 times the tangent of theta over 1 minus the tangent squared of theta. All right, so we just need to plug into this. Okay, if we go back to our previous work on page 2, okay, where we did all the hard work, we know the value of the sine of theta and we know the value of the cosine of theta. We need to get the tangent. Okay, so you could take the sine value and divide it by the cosine value. That works just fine, but the easiest thing to do is to just read it off of the triangle. Okay, the triangle, we know the tangent is the opposite over the adjacent. Okay, So I'm going to write it right here, and then I'll move it on to the next page. The tangent of theta here is just going to be opposite over adjacent. And so this is going to be negative square root of 5 over the square root of, well, I'll put 2 square root of 11. Okay, and I'll work with it from there. Okay, so I'm going to copy this over to the next page. Okay, so we know that tangent of theta is equal to negative square root of 5 over 2 times the square root of 11. Okay, I'm going to go ahead and rationalize the denominator here. All right, so this is going to be negative square root of 5 times square root of 11 is the square root of 55. In the bottom, we're going to have 2 times the square root of 11 times the square root of 11 is 11. So this is negative square root of 55 over 22. That's the value of the tangent of theta, and that's what we should be popping into this equation. Okay, so let's go ahead and do that. We're going to have 2 times the tangent of theta. That's going to be 2 times negative square root of 55 over 22. Okay, and then we're dividing that by 1 minus the tangent squared of theta. So write down the tangent, negative square root of 55 over 22. We need to square this value. Okay, we're going to simplify this, and then we will be done. Okay, in the numerator, okay, 2 goes into 2 one time, 2 goes into 22 11 times. We're going to have negative square root of 55 over 11. In the bottom, we've got 1 minus, and then we're taking negative square root of 55 and multiplying it, or sorry, negative square root of 55 over 22 and multiplying it by itself. Okay, so this is going to be, well, here, let me give myself more room. This might get messy. Okay, let's go over here. This is going to be negative square root of 55 over 11, and then in the bottom we're going to have 1 minus, negative times negative will turn it positive. Okay, so we need to multiply across the top. The square root of 55 times the square root of 55 is going to be 55. The bottom is going to be 22 times itself. So we are going to get 22 times itself. Okay, we're going to get 484. All right, so we keep going. Negative square root of 55 over 11. In the bottom, we need to get one fraction. Okay, 1 is 484 divided by itself. So we have 1 minus 55 over 484. And then I'll leave the numerator alone. In the bottom, I have a fraction with denominator 484. The numerator will be 484 minus 55. That's going to be 429. Okay, and now I just need to divide the fractions here. Okay, so I'm going to get negative square root of 55 over 11 times, I'm changing division to multiplication, flip the bottom fraction. Okay, 484 over 429. Okay, this is a nasty number. All right, let's see what we get. I'm not going to mess with the radical here, okay? I'm going to leave the square root of 55 as it is. I'm going to go to my calculator and see if I do 484 divided by 11 times 429, if that gives me a simpler answer. So 484 divided by 11 times 429. Okay, so I get a decimal, convert it to a fraction. This is going to be 4 over 39. Okay, so that's what this part turns into. Okay, so we're going to get, this is 4 over 39. Okay, don't forget the negative sign and the square root of 55. Okay, so it's going to be negative 4 times the square root of 55 all over 39. Okay, that's your answer. That was messy. Okay, I want to show you something with this particular problem in part C. Okay, this is the tangent of 2 theta. I'm going to come up here. Okay, when I did this work in part B, okay, I used a double angle formula for tangent. Okay, here's another way you could have worked it. Okay, and it might be easier. Okay, if I'm trying to find the tangent of 2 theta, 2 theta is an angle. Okay, all I have to do to get its tangent is take its sine and divide it by its cosine. Okay, so we could have gotten this answer by simply doing the sine of 2 theta divided by the cosine of 2 theta. Okay, and we know what these guys are because we've already done it. So back on page 2, we figured out the sine of 2 theta is this mess, negative 4 times the square root of 55 over 49. So negative 4 times the square root of 55 over 49. And in the bottom, we need to put the cosine of 2 theta. We figured that out in part B. Okay, in part B, we said it's 39 over 49. And you can see this is a lot easier. Okay, you jump straight into, two fractions that you're dividing. So let's leave the top fraction alone. Change to multiplication, flip the bottom fraction. And yay, hooray, these 49s cancel, okay, and you're left with negative 4 times the square root of 55 over 39, okay. If I come down here, look at what I got with all that work. The same thing, negative 4 times the square root of 55 over 39, okay. So obviously, the second method I did was a lot easier. Okay, if you didn't recognize that, that's okay. You could have obviously applied the double angle formula for tangent and gotten the same answer. Okay, but again, this is just a heads up that, the more you learn, you have a lot of options for working a single problem. Okay, there's different ways to do things and arrive at the same correct answer.